In this video, we're going to write a simple C# application using the RAMP API, or Application Programming Interface. So the objectives for this tutorial will be to read a raster file, generate the spatially localized statistic for the value range in a kernel, and render that resultant raster to a bitmap file using a minimum to maximum or linear color stretch, and then finally save the new raster file to an output location. So to start off, I'm going to start up Visual Studio, which is my preferred integrated development environment. But you might choose to use different development environments such as MonoDevelop, or you might even just want to use a simple text editor like Notepad and compile it at the command line. But I'm going to use Visual Studio, so I'm going to start that up now, and I'm going to create a new project. So create new project. I'm going to choose to do this as a console application. So let's select that. Next, and I'm going to call it tutorial example 1 and create. So you can see it's started off with a simple console application that has a namespace that is the name of my project. It has a class within there called program, and it has the main entry point method, the static main method, which is where I'm going to write my code. I'm going to remove some of these things here that I don't need. And the first thing that I need to do if I'm programming using RAMP is to add a reference to my RAMP libraries. And the first library that I'm going to reference is the RAMP core library. So under references here, I'm going to add a reference, and I'm going to browse to my RAMP installation directory, which is here, and I'm going to choose the RAMP core DLL. So let's do that. Okay, and it's added that as a reference. Now I need to tell it the compiler, or tell the compiler that I'm using the RAMP namespace. So let's recap what that means by looking at the RAMP API documentation just briefly. So here's the documentation, and remember that the most important library in RAMP is the RAMP core library, which has the namespace RAMP. So what I just did was I added a reference to this dynamic link library, and this library uses the namespace RAMP. So I declared that at the top of my before my namespace declaration in my project. Now I'm going to template my workflows. So the first thing is read the input raster. The second one will be generate the local statistics, render the output, and then finally write the output raster to a new file. They're my main processing steps. Okay, so how am I going to read the input raster? Well, RAMP has a very useful utility in the RAMP core utils called read. And so I can just call this, give it a file, and give it a format specifier. So let's have a start to look at that. So I'm going to declare a raster, because if I go back to my documentation, this method returns a raster object. So raster, and we'll call it input raster, equals utils.read. And now we just need to specify the location of that file. So let's say sample data, and let's just call it bathy.rmp. Now it also wants to know the format, okay, and that's a string. So let's go back and have a look at the documentation and see what we need to put in here. So, string input file, string format. It says refer to here refer to the readers and writers documentation for a listing of the standard format codes. So let's click on that. And what I'm trying to read is a ramp binary grid, and it says the format code is ramp. Okay, well that's easy. So I just put in here, ramp, done. So that's the first step completed. I've read this input file, and it's returned to me a raster object. Okay, now we need to generate the local statistics. So how are we going to do that? Let's go back to ramp and have a think. So in ramp, I know that I have a local statistics processor, and I quite like using the range. So let's scroll down to the bottom, and indeed there is a method in here in the Processors Dll, in this particular namespace and class, called range, and it allows me to pass a raster and a kernel size, and it will return a new raster, which is the range of the kernel size. So I need to firstly add a reference to Processors.dll. Let's do that. So back in Visual Studio, I'm going to add a new reference, and this time I'm going to browse, and I'm going to choose Processors.dll. So let's add that. Okay, now let's tell ramp that we're going to use that too. So using ramp.processors. Going back to the documentation, I can see that there's a class called local statistics that I need to call now. So what we're going to do is we're going to call that, and we're going to call the, or going to go there, and we're going to call this static method called range. So declare a raster, and this will be called the range raster, and it's equal to local statistics dot range. And it's saying you need to give me an input, okay, no problem, input raster, and a kernel size. Let's use a kernel size of 9. So that's done. I've now calculated my localized range statistic. The next step I need to look at is how do I render this output? Okay, let's go to the documentation and see what rendering options I get. So I know that there is a rendering processor, and generate map linear looks like it generates a color map using a linear stretch, and then if I want to render it, I can render a color map, or I can render a raster using a particular color palette. Let's look at that option. Okay, cool. So let's use that. Firstly, I need to get a color palette. Let's scroll down, look at it. Public static void render. You give it a raster, you give it a color palette. Okay, so I need to create a color palette. How do I do that? Let's go to the API reference and look for color palette. Color palette. I'll need to add the renderers library. Let's do that first. So I'm adding a reference to renderers. Okay. And I needed to get a color palette, so let's do the first sub-step. It's get the color palette. How do I do that? So my documentation should tell me. Color palette. So it's in ramp renderers. Oh, when I construct, I just pass the location of the color palette file. That's pretty easy. Let's do that. So, color. Oh, I haven't told it I'm using it yet, so let's do that. Using ramp.renderers color palette. Color palette, let's call it CP equals new color palette, and I'm going to tell it what color palette file to use. So this will be in my installation directory, and I'll show you where they are. In my installation directory, I have a subdirectory called colors, and in there it contains all my color palettes. So I'm going to do something, let's use the, there's one in here called default, which is the default one that ramp uses. So let's take this folder and then we'll use default.col. So blah, 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 default.col. Great, so that's my color palette. Now I need to render. So if I go back to the documentation again, rendering, and we were going to use render palette, and in rendering.render, I can specify a color palette, a raster, a stretch type. The stretch type is linear. Whether I want to invert it, what the alpha blend is, okay, great, and output file. So that's brilliant. Let's do that. Rendering.render. There's three options. Firstly, I need to put in the range raster is the one I want to render, then the color map, which I called CP, and then it's asking for the stretch type, which is linear, and then do I want to invert it? No. False. What's my alpha blend? Let's read the documentation for that. Alpha, the alpha transparency value of the output image. Values range from 0, fully transparent, to 255, fully opaque. So we want to give it 255. Then it's asking for an output file name. So let's put it in e/sample data bathy.bitmap. And then what else did it want? It wanted to know the world file extension. So the world file extension for a bitmap is BPW, if I'm not mistaken. Okay, so that's done. Now I need to write the output raster to a new file. Well, I can just call utils.write, give it the range raster, and tell it where to put it. So let's put it into sample data range bathy.rmp, and we will choose the ramp output file format as well. So essentially, my job's done. What I probably want to do is just put some console output in here. And what I'll actually do is I'll call the ramp utilities to do that because it gives me more useful information. So signal start utils.out starting, and at the end we'll say utils.out done. And so that we pause at the end, I'll ask the console to read a line. That's just going to pause for me at the end. Okay, so there we go. How many lines of code really to do this? 1, 2, 3, 4, 5 lines of code to do that workflow. Let's run this now and see what happens. Okay, so when I run it, I get this error. And why do I get this error? Let me explain. When we added the dependencies, the references to the processors, ramp core, and the renderers DLL, it's set to, let me show you, it's set to copy these to the local folder that it's compiling the output to. And it turns out that these DLLs have some dependencies, and most of the DLL dependencies are also copied into the output folder. But the tools.def dependency is not. So let's go have a look at the output folder for this project and see what it's copied, and then we will copy the tools.def file into there and then see what happens. So this is the output folder that it's tried to compile to. It's the debug folder that when I click play in Visual Studio, it has started to build to. And you'll notice that it's copied renderers, ramp core, and processors, plus all those things that, all the other DLLs that it has dependencies on. But what it doesn't have in there is some of the other file dependencies, like tools.def, for example, is the one that it's complaining about. So I need to go to my installation directory and then copy that tools.def file into here. So let's do that. So that's here, and I'll look for tools.def, copy, and we will put it into this folder here. Tools.def is now in here. Let's now rerun the project and see what happens. And you'll see it started, it's done the job, and it's completed. Okay, let's go now and have a look at what the original input Bathy looked like. Let's have a look at the bitmap that it generated and also the file that it saved out. Okay, so here's the original input file, bathy.rmp. Let's go check out now the bitmap that it rendered. And it created bathy.bitmap. Let's open that up and have a look. And there's the file that it rendered. Very nice. Let's now have a look at the raster dataset that it exported for this in the RAMP graphical user interface. Okay, so that was a RAMP raster called range Bathy. I render it, and there it is. Because my bitmap looked exactly the same, because it used the default color palette, and also RAMP graphical user interface uses the default color palette. But of course I could change this to whatever I wanted to and have it render in that way. So this has been a quick tutorial into how to generate your own C# application that leverages the RAMP application programming interface. What you need to remember is that to reference your dynamic link libraries that you're using and to copy any other dependencies that might be missing, but the compiler will tell you that they're missing. So you can see that this code could scale to whatever level of complexity that you'd like it to. So I hope this has been a good introductory video to creating applications using C# and the RAMP API. And I hope you enjoyed the video, and thanks for watching. Bye.